looking at the notes that look like this, remember we went through the mean, the median, and the mode. We did a lot of work on that. And these were numbers that didn't describe like how, where the numbers were positioned in a set of data, but it kind of like summarized the data to figure out like where the center might be, right? So the mean is near the center, the median is near the center. The mode isn't really, but we still kind of say it's a measure of center, okay? We're going to talk about a different type of measure of center today. And it doesn't really summarize where the center is, but how far away the numbers are from the center. So once I get my notes here. Okay. So to kind of explain what these numbers are, what these values are, let's take a look at two different sets of data and try to describe how they're different, okay? Now, if I were to find the mean of the numbers on the left, what would I do? Harris? And then what do you do? Perfect, right? I would take all the numbers, add them up, divide by 5, right? So -2 plus -1 plus 0 plus 1 plus 2, all divided by 5 is 0. Perfect. I can also do the same thing with the one on the right. I will take -20 plus -10 plus 0 plus 10 plus 20. Yeah, right. Like they kind of cancel each other out in both cases, right? The -2 and the 2 cancel each other out, and the -10 and the 10 cancel each other out. So the means are actually the same of these two types of data, right? The data on the left is the same mean as the data on the right. So what exactly makes the two sets of data different? Aside from the numbers. Isn't one more spread out than the other, right? The data set here, the numbers are further away from the mean 0 than the numbers here, right? The numbers on the left are closer to 0. The numbers on the right, oh gosh, are further away from 0, okay? And this is what we're going to focus on today. There's a number called the standard deviation that talks about how spread out the data are, okay? Now, this number is called the standard deviation. It's a number that summarizes how further away from the mean that we are. If we have a large standard deviation, it means that the data is more spread out. So it looks kind of like this, okay? If the standard deviation is really small, then it's talking about a set of data where the numbers are closer to the mean, okay? So small standard deviation, data is closer together. Larger standard deviation, data is more spread out, okay? So I kind of just answered this, but in this example on the top page, the data on the right has a larger standard deviation, right? So the data on the right has a bigger standard deviation because the numbers are spread out more. Now let's take a look at the next question, okay? Here we have two graphs. I know we haven't looked at graphs that look like this before, but basically it's like a histogram of the data, okay? So we have the dotted line, the dotted red line is one data set where it's like a histogram where we spread out all the data in this chart. And then the black line that kind of goes up is another set of data, it's another histogram. Put them on top of each other, okay? Now, the mean of these data points, I'm going to tell you, is right in the middle. And we'll talk about why that is in the future. Can someone tell me which one has the larger standard deviation? The one that's low, right? Because it's more spread out, right? The data are spread out more. They're not close to the mean, they're further away from the mean, okay? So this one has the larger standard deviation because it's more spread out. Okay. Any questions on like kind of the idea of standard deviation? That's good. Okay, well, since we know what it means, the standard deviation is a number, which means we can calculate what it is, which I know we love calculating things. Now there is a funky formula for the standard deviation. I don't like to use it because I feel like there's a more step-by-step method to do it. If you want to know the formula, just ask me after class. But here are my steps to find the standard deviation, okay? And I think if you have the steps and you have the organization, it's really easy, okay? The first thing you're going to do is you're going to find the mean. Okay, so you're just going to find what it is. You're going to take each data value and you're going to subtract off the mean. So you're going to subtract the mean from all the data values, okay? Once you do that, you square your answers from part 2. You add them up and divide by the total number of values that there are, okay? We actually call this number the variance. Then once we do that, we're going to square root the variance, or the number that we just got, and we get our standard deviation. I know that sounds like a lot of jumbled steps. Let's just go through an example and it kind of will give us an idea of how to actually put this into practice. Okay, so we have -2, -1, 0, 1, 2. Hey, that's our last example. I found the mean on the last page, but in order to find this, you would add them up and divide by how many, right? And I think we found that to be 0. Okay. Okay, step 2 says to take each data value and subtract off the mean. Okay, we're going to do that in this column here. Okay, well, this is pretty easy since the mean is 0. Let's just subtract off 0. Okay, so let's do -2 minus 0, -1 minus 0, 0 minus 0, 1 minus 0, and 2 minus 0. Okay, oh, it looks like we got the same numbers, didn't we? Okay, step number 3 says to take our answers and square them. So let's do that. What's -2 squared? 4, right? When you square a negative number, it turns positive. So all of these answers in this column have to be positive, right? So 4, -1 squared is +1. 0 squared is 0. 1 squared is 1. 2 squared is 4. Okay. Now on your notes, if you didn't understand the squaring to be positive, just make a note for yourself that the answers in these columns have to be positive, okay? If you're getting a negative answer in that last column, then you're doing something wrong. Okay, looking at the steps, what's my next step? Add them together, right? So 4 plus 1 plus 0 plus 1 plus 4 is 10. Okay, so we got the sum. Step 5 says divide the sum from step 4 by the total number of numbers that there are. Okay, so what am I going to divide 10 by? 5. Good. Okay, 10 divided by 5 is 2. And my standard deviation is the square root of the variance, which is what I just found. So the square root of 2, that's my standard deviation. You don't have to make it into a decimal if you don't want to, but let me just do it. I think it's 1.41. Okay, you don't have to do that. You can leave it as a square root. Any questions on how I got the standard deviation? Okay. I feel like normally when I first learned about standard deviation, I was given a formula and it was so confusing what to plug into the formula, but I think the step-by-step method makes it a little bit easier. All right, next we have example number 2. This is the next set of data. I'm going to give you some time to find the standard deviation of this guy. Very nice answers as I've been walking around. Remember, we have the second set of data here with the -20 through 20. Who did I have to go first? Oh yeah, okay. So I got Alex to write up the first row and the mean. Do you kind of want to take us through your steps here?
I mean, we knew from before that the mean was 0, just by adding everything up and dividing, and then subtracting the mean is just taking all the values and subtracting 0. 0 is -20 minus 0 is -20. -10 minus 0 is -10. 0 minus 0 is 0. 10 minus 0 is 10, and 20.
Perfect. All right, and then I think I picked on, who did I pick on next? Was it Jessica that I?
Yes.
Did you write it? Okay. Yeah. Do you want to take us through these guys?
Okay. So I know that -20 squared is a positive number, which is 400.
Mm-hmm.
And then 10 squared would be 100. 0 squared is 0. And then 10 squared is 100. 20 squared is 400.
Perfect. Sorry to make you explain all of that, but yeah, nice job. Then I got Megan to write up the sum, which is great. Do you want to take us through how you got the variance and standard deviation?
For the variance, I just took the sum and divided by the amount of data values to get 200, and the standard deviation is square.
Perfect. Perfect job. So square root of 200 is the variance. Now, I'm actually going to type that in my calculator and see what value that is. I don't know why I always click my clock when I want to type the calculator, but let's see. I'm getting 14.14. Okay. Now we did say, we predicted in the beginning that the numbers on the left, like the -2 through +2, had a smaller standard deviation than the numbers on the right. Let's just do a little check. We got 14.14, which is what we expected it to be, which is the standard deviation we expected to be bigger. The first one was 1.41. So we definitely got a way bigger standard deviation for the numbers that were more spread apart. Okay. Any questions on example 1 or 2? All right. Okay, so the mean doesn't always have to be 0. I know I gave you 2 examples where the mean was 0. Let's do example 3. I feel pretty confident we can do this one. So hopefully by the end of class, we're going to be experts in finding the standard deviation. People are writing up. So we got 4 numbers this time. Who wrote up the mean? Was that Ashley? Do you want to take us through finding the mean and subtracting it off?
So I added up the 4 numbers and I got 8, and then divided by the amount of numbers in the first 4 and got 2.
Perfect. And then I guess you subtracted the mean. Nice job there. I got Kamira to square the answers. I don't think you really need to explain too much, right? Squaring the answers, did a great job to get these numbers, and you added them up to get 14. All right, then, Caroline, do you want to take us through how you got the variance and standard deviation?
So I just took the sum and divided it by the number of values that we have, got 3.5, and then did the square root, got 3.5.
Sounds great. All right, do we feel confident to find the standard deviation on the test on Friday? Nice. All right, so that's all I have for you today. Didn't really have anything else planned. So Wednesday we'll do review for the test, and Friday we'll take our first exam, which is